Hey guys, so we already dealt with probability distribution. We talked about using probability distribution to help us with expected value. And now what we're going to do is we're talking about binomial distribution. Now, when we get to our binomial part, and we're going to explain all that good stuff, binomial, just think of bi meaning two. Oh, sorry, didn't hit the right thing. Think of that being two. So when we talk about two things here, talking about binomial distribution, we're going to talk about two today. So let's go. Let's move forward. Let's go into this thing. That's the bad boy. All right. So before we go into the actual notes and stuff, we're reviewing because we need to make sure that we understand what these mean. Because if we don't, that means if the work is going to be hard and we can't be able to do these notes and everything and actually understand what's going on. So with that, it says at least 60 people. If we talk about, okay, if somebody walks in, and that should say at least, sorry. Let's fix that really quick. So at least 60 people. So if I say, okay, there's at least 60 people in this classroom or in your workplace or at home or in a coliseum or something, movie theater, what does that mean? And hopefully you just said in your mind, that means 60 or more. So there's at least 60 people in here, but there could be more. So 60 or more. So I hope you said that. But also another thing we're going to do is go ahead and put it in the inequality form. So there could be 60 or more. So we have to have the equal to sign there, including 60. All right, so if there's no more than 60, if you say there's no more than 60 people in this room, that means, okay, there could be 60 or less. So there's no more than 60, but there can at least be 60 or less. So that'll be our x is less than or equal to 60. All right, we're going to have about 5 of them up here, I believe. 5 or 6, 5, okay. So here, the next one says fewer than 60 dogs. So if I say there's fewer than 60, that means there's not 60 there. There's stuff that's fewer than that, lower than that. So that means less than 60. So x is less than 60. All right. So if we say exactly 60 problems, that means, as one of the students said, it's just 60. So it doesn't go above 60, doesn't go below 60, it's just 60. So x just equals 60. All right, and then the last one says more than 60 tweets. So if there's more than 60 tweets there, that means we actually have more than 60 tweets. Which means that x is greater than 60. So if we say at least or at most, that means that we're talking about that number and other numbers. So in other words, if it's at least 60 or at most 60, 60 is going to be a part of it, but then you can go above or below. All right, cool. So as we've gone through this, we're going to use this for our notes that we're getting ready to take. So keep this in mind. Don't forget it. And let's move forward. Let me fix that real quick. All right, there we go. All right, so let's move forward. So when it comes to our binomial distribution, when we talk about binomial, like I said at the beginning, it means two. Dos. Two. So if that means two there, that means that when we deal with this, like the difference, in other words, between here and what's going on with our expected value, regular expected value, that means here we only deal with two outcomes. So just like you think about expected value, we talked about rolling a die, which had like 6 outcomes. We talked about one of them was like we had a bag of money and we had to pull out money. And I think there was like 4 different types of money in there. So there was like 4 different outcomes you can have. So when it comes to binomial distribution, though, we're talking about just 2 outcomes. So it's either success or failure. Right? The other thing, there's always going to be a fixed number of observations. And so, guys, with this, as we're going through it, and I don't think I actually explained that. These are what makes a binomial distribution a binomial distribution. If one of these does not work, it is not a binomial distribution at all. So everything has to work here to make sure it works. It is a binomial distribution. So here, again, 2 possible outcomes. It has to be a fixed number of observations, fixed number of trials. So if we say we're going to flip a coin, well, let's say that we're going to roll, let's say flip a coin like 20 times. The number of times that we're flipping the coins is your trial, the number of trials, your fixed observations. All right. The third thing is all three of these, or all however many trials you're doing, have to be independent of each other. So if for example, let's say I flip a coin. If I flip a coin, it's either heads or tails. If I flip it again the second time, it's still going to be just heads or tails. Doesn't matter what happened that first flip. We're just on a brand new trial, and it doesn't really matter what happened on that first thing. So it's independent. All right, and then the probability of success for each trial is the same. So the probability of success, like in other words, the probability of it happening is going to be the same no matter what. So for the first one and the second one, it's going to be the exact same probability. All right, so those are the four things. So let's do a quick not review, but a quick example here to make sure we understand, because you're going to have to know first before you even start trying to do work to see if it really is a binomial distribution. If it's not, then you just stop and say it's not. All right, so for example, again, we're going to go back and look at those 4 steps that we have up there, 4 characteristics. So let's say flipping a coin. Would it be considered binomial? And as you can read up here, it says, yeah, flipping a coin would be considered binomial because, and let's see why. Let's see why it is going to be considered a binomial. For one, if we get heads, that could be considered success, tails could be considered failure. Or we can flip it around and say tails is success and heads is failure. It still has 1, 2 different outcomes. So 2 outcomes. It's binomial. Number 1, check. Right? Number 2, it says we're doing it 10 times. So we're flipping the coin 10 times. So that means our number of trials is going to be 10. So there's a fixed number of trials. That's step 2. Check. All right. Then we come here to step 3. Every flip is independent, and that is the result of each flip has nothing to do with the result of the preceding one, the one that happened before. So if I flip a coin, yeah, it doesn't matter what happened last time. It's this. So that takes care of step 3 that says they have to be independent of each other. But then before we get to step 4, let's think about this. What's the probability of getting a heads? So if we have 2 sides, 2 outcomes, heads is going to be just one of those outcomes, right? So the probability of heads is 1 out of 2. Okay, so let's say, what's the probability of tails? Well, wouldn't it be the same thing because it's 2 outcomes, heads or tails? Tails is one of those 2 outcomes. So it's 1/2 again. So step 4 said that the probabilities have to be the same throughout the whole thing. And look at this, it does. We get 1/2 for every single time you do it. So 1 out of 2 every time. All right, so now let's go into an example where we're going to deal with this part here. Oh, I told you wrong. There's not an example yet. We're going to talk about what the binomial distribution is going to look like because we're going to do it in desmos, so as you saw on the title. So here, when doing this, you may see the BNP. So this part right here, you may see that. And the reason why I'm showing you guys this is you might see this different ways. Like there's a way to do it that it looks like in the TI-84 calculator. There's a way that it looks in Desmos. And then there's just a way that people just write it out originally before you do any of that stuff. So one of the original ways that you write it, or you could see it, and you might see it like throughout the activities for this, you could see that written the way that's circled right here in black. The B meaning binomial distribution. And then this with N and P. We'll talk about that in a few seconds right below this. But that is a way that you can see it. All right. Now, we're going to see it the following way. Because, again, we're doing with Desmos. We're going to see it like this. Again, the TI-84 is going to look different. And if you do it in an Excel sheet or something like that, it's going to look different too. But here, N is going to be that number of trials. So pretty much just like we talked about number 2, step 2, there has to be a fixed number of trials. N is going to be that number of trials. P is going to be the probability of success. So probability of success that something's going to happen, that's going to succeed at what they're trying to get. So that's what's going to be here. So here you have binomial dist, which means binomial distribution, but binomial dist NP. All right, so with that, we're going to go into Desmos and everything and do these activities and everything, these examples, and then we'll be good. So let's go.